Question 1. How many of the following four numbers are prime? Well, I know 3 is prime, so that's one of them. 33, that's going to be 3 times 11, so that's not prime. This is going to be 3 times 111, so that's not prime. And that's going to be 3 times 1111, so that's not prime. So the answer there is B, only 3. Question 2, 3 positive integers are all different. They're positive integers and they're all different. Their sum is 7. What is their product? Let's see if we can find what they are. Positive integers, all different. Sum 7, they must be quite small. If we do 1 plus 2 plus 3, that makes 6, so that's not it. If we had 2 plus 3 plus 4, that makes 9. It's got to be 1 plus 2 plus 4, that makes 7. That's the only way you're going to make 7. So effectively they're your integers. We want to find the product of 1 times 2 times 4, and that's going to equal 8, which is D. Question 3, equilateral triangle, square, pentagon, all have the same side length. Triangle drawn on and above the top of the edge of the square, and the pentagon is drawn and below the bottom edge of the square. What is the sum of their interior angles? I could just go and use the fact I know that's 180, that's going to be 360, and that's going to be 540. Add them together, but the answers are in terms of times 180. Well, I suppose that's 1 times 180, that's 2 times 180, and this is going to be 3 times 180. That makes a total of 6 times 180, which is answer E. Question 4. All 4 digits of two two-digit numbers are different. What is the largest possible sum of 2 such numbers? If I'm going to get the largest sum, I want the biggest numbers. And not only do I want the biggest numbers, they're in 2-digit numbers, so I want the biggest numbers in the tens column. So I'm going to put the 9 and the 8 in the tens column. And next to biggest, since they've all got to be different, is going to be the 7 and the 6. So now I'm going to get biggest tens and the biggest units answer. So if I add them together, I'm going to get 7 and 6 makes 3, carry 1, and that makes 18, 183. Question 5. How many minutes will elapse between 2012 today and 2102 tomorrow? Let's go and just see it for today. I'm going to start at 2012 and go to 2102. In fact, I'll go to 2100 hours, then I'll go to 2102. I'm happy with that because that there is going to be 48 minutes, and then that's another 2 minutes. So today we've got a total of 50 minutes to take us to the correct time, but then I've got to add on another 24 hours. That's going to be add on 24 hours of minutes times 60. That's going to be 50, add on 60 times 24, that's going to be 441. So add 50 to that, we're going to get 1490, which is D. Question 6, triangle QRS. QRS is isosceles and right angled, so that's the same as that. Beatrix reflects shape P on the side QR, that's that side. It's going to reflect, so the reflection is going to be looking like that. That's the first reflection. She reflects the first image, that's the first image to side QS to get a second image, so that's QS, that's in this one, so that's going to be reflected. Try and do it accurately, otherwise I won't. So that's my second reflection, and then she finally reflects the second image inside RS, that's this one here, to get a third image. What does the third image finally look like? Now this is in a diagonal line, so if I move that down a little bit, this point I'm doing the distance at perpendicular, so that one's got to be the same distance from there. And if I compare this line here, that line's going vertically, so this line will go horizontally, and that P, it goes down and the p's at the end there, so it's going outwards further away from the line, so it goes there and further away from the line. That's going to be my final image. On the exam I could do this on a bit of scrap paper and fold it in half and just double check. That's my final image, which is A. Right, question 7. The prime numbers P and Q are the smallest primes that differ by 6. What is the sum of P and Q? This should be a straightforward one. I'm just going to write out my primes. 2, 3, 5, 7, not 9, 11, 13, not 15. So I could keep on going. It says differ by 6. Let's have a look at the difference. If it's 2, then my next number would be 8, so that's not one of them. If it's 3, 6 more is 9, so that's not a prime. 5 and 6 is 11, that's the one. It's 5 and 11. Let's check. Prime numbers P and Q are the smallest prime numbers that differ by 6, so it's 5 and 11. What is a sum? It's 5 plus 11, which is 16. That's C. Question 8. Seb has been challenged to place the numbers 1 to 9 inclusive in the 9 regions formed by the Olympic rings. So there is exactly one number in each of the region, and some of the other numbers in each ring is 11. Some of the numbers in each ring is 11. The diagram shows part of the solution. What number goes in the region marked star? So I want that number there. Well, let's have a look. We've got a 9 there and a 5. Well, this must be 2. I haven't used the 2. In fact, I'm going to make a note of the numbers I can use. I can use 1, 2, 3, 4, 5, 6, 7, 8 and 9. I've used 9. 5 is already there. 8's already there. I've just put 2 in there. It must be 2 because that ring must make 11. This is 2 and 5 is 7. So this one must be 4 in there to make 11 in that circle. What else do I know? Can't do that one because there's 2 regions. I know this one here, that one must be 3 to make 11 in that circle. Now I've got 3 numbers left and 3 regions, and I've got to do it so it makes 11. So these 2 could be 6 or 7 or 1. They've got to make 3, so those 2 regions there have to make 8. So those 2 must make 8, and then these 2, because I've got a 4 in there, must make 7. How can I do that? I think I've got to have a 6 and a 1 and a 7. That'll work, won't it? If I put 1 in the middle there, and then I put a 6 there and a 7 there, that makes our 8 and 11, and that makes 6, 4, and yeah, that's it. So it's 6. 6 is the number which I put in the starred region. Auntie Fi's dog Itchy has 1,000,000 fleas. His anti-flea shampoo claims to leave no more than 1% of the original number of fleas after use. What is the least number of fleas that will be eradicated by the treatment? So it leaves 1% after use. So we want 1% of 1,000,000, which is 6 noughts. So 1% of 1,000,000 is going to equal, we'll cross off a couple of the noughts, which is 4 noughts. So that's 10,000. And we want, that's how many is left. So what's the least number of fleas that will be eradicated? So the least that will be, it's going to be 1,000,000, 1,000,000. Take away the 10,000, so that's going to be, that comes to 100, take away 1, so that's going to be 99,000, so 2 9s and 4 zeros, that's B. Question 10. An abundant number is a positive integer n such that the sum of the factors of n, excluding n itself, is greater than n. What is the smallest abundant number? Let's get this straight. The sum of the factors of n. So let's write the factors of 5, which is going to be 1 and 5, excluding n. So it doesn't count that. So the sum of the factors of n there is just going to be 1. An abundant number is a positive integer n, so the sum of the factors of n is greater than n. So I need something greater than 5. It's not. So factors of 6 are going to be 1 and 6 and 2 and 3. I don't include 6 itself, and the sum of those are 6. That's not greater than. It says greater than. That's equal to. I want the smallest abundant, so I'm starting with the smallest number here. Factors of 10 are 1 and 10 and 2 and 5. Can't count 10. Add up the others. I get 8. It's not bigger than 10. 12, 1 and 12 and 2 and 6 and 3 and 4. Can't do 12. Add up the others. That gives me 10, 16. That is bigger than the number. So that is an abundant number, and because I've worked from smallest to largest, it's the smallest abundant number, 16. Sorry, the answer is 12. That's the one. Question 11. In the diagram, PQRS is a parallelogram. PQRS, that is a parallelogram. That's a very useful piece of information. SPT is 62, they've marked that on, and PT equals, so they've put the little dashes on there. What is the size of angle QR? QR, where's QR? Sorry, TQR. From T to Q to R, so it's that angle there, from T to Q to R, it's there. It looks like it should be a right angle, but we can't assume that. We've got to work out that angle there. Now, what do we know that helps? Well, first of all, let's take this as a parallelogram. If it's a parallelogram, now this angle here with a parallelogram, adjacent angles add up to 180, so that angle is 130. That means this whole angle here is going to be 130. It also means this angle in here, that angle is 50. Either because I know adjacent angles add up to 180, or in a parallelogram, opposite angles are the same. So if that's 50, I've now got an isosceles triangle here. I'll just copy that isosceles triangle so you can see it there and there, and that's 62 and 50, that makes 112. So that angle in there is 112 degrees, and these two angles must be the same because it's an isosceles triangle. So if I do 180 take away 112, that's going to give us 68, and then that's equally split between those, so those two are 34, so that's 34 and 34. That means up here, this bit here is 34, but we knew the whole lot was 130, so the angle that we're missing in red is going to be 130 take away 34, and that's going to give us 96, which is answer C. Question 12. Which one of the following has a different value from the others? I think I'm just going to leap into this and work them all out. I'll do them as fractions because I don't like dealing with decimals if I'm not got a calculator. So that's 18% of 30. That's 18 over 100 times 30. So that's going to cancel there, and that's going to give us 18 times 3 is 54 over 10, 5.4. It says it's different value from the rest. So if I find one, well, let's see what this one is. This is going to be 12 over 100 times 50. So that's going to be 12 times 5 over 10. 12 times 5 is, that's 0.6. Sorry, 12 times 5 is 60 times, that's just 6. This one's 6%, so that's 6 over 100 times 90. Cancel that, so it's 6 times 9 over 10, which is 54, 5.4 in fact. In fact, I don't have to go any further. I just have to go and check this. This was 12 times 5 is 60 over 10 is 6, so that one's different to those two, so we're only looking at one answer, so it's this one, B. Alex, Elric and Panthus Farkas showed shared an opening rally of 2 hours and 12 minutes during their table tennis match at 1936 World Games. Each player hit around 45 shots per minute. Which of the following is closest to the total number of shots played in the rally? 45 shots per minute. About. Well, that's going to be 90 shots in all, isn't it? That's going to be 90 shots per minute. So that's going to be 90 per minute. So 2 hours. 2 hours is going to be 120 minutes and 12. So that's going to be 132 minutes. So I want to work out 90 times 132. So if I make that a bit of an easier calculation, I only need the approximate thing. I will do 90 times 130, which is the same as 90 times 130. So that's going to be 9 times 3 is going to be 27. 9 times 1 is 90 plus a 2 is 11,700 approximately. So that's going to be D, closest to 12,000. Wow. Question 14. What value of x makes the mean of the first 3 numbers in this list equal to the mean of the last 4? If I work out the mean of those numbers there, it's going to be adding them together plus the x and divide by 3. And that says it must be the mean equal to the mean of the last 4, so that's going to equal the mean of the last 4, which is adding them together and dividing by 4. So now it's just solving that equation. And the way I'm going to do it is I'm going to cross multiply, so it's going to be 4 times this lot here, which is 20 plus x, equals 3 times this slot here, which is x plus, that's 24, 33. So if I expand out the brackets, I've got 80 plus 4x equals 3x plus 99. Switch them over, so it's 4x minus 3x, which will give us x equals 99. Take away 80, so that's going to be x equals 19. That's the answer A. Question 15. Which of the following has a value that is closest to 0? I don't necessarily have to work out the exact value it is, I just have to work out which is closest to 0. I guess I'm just going to do these calculations. That's going to be half. I'm going to do the multiplication first because that's in BODMAS, so that's half plus a 12th. I'm not going to evaluate that because I don't think I'm going to have to. This one here, half plus that's going to be half plus, effectively that's a third times 4 over 1, that's going to be half plus 4/3. Now that is going to be much bigger than that one, so it's not going to be B. This one, it's all in one, it's going to be half times a third times 4 over 1, so that's going to be 4 at the top and 6 4/6. Now that is more than that's going to be more than a half, but I don't know if it's as big as that, so I'll just leave that for now. Come back to it. That's going to be half minus, that's going to be a third times 4 over 1, so that's going to be a half minus 4/3. That takes us negative. I won't evaluate yet that in case I don't have to, and this one's going to be half minus a 12th. That's going to be less than a half. That's more than a half, less than a half. That's going to be further away from 0, so that one doesn't have to be included. This is less than a half, that's clearly more than a half, so it's not that one, it's between these two. Just which one is it? This is a little bit less than a half, this is half take away more than 1, so that's going to be greater than minus a half. It's going to have to be E. I haven't actually evaluated them all, but I've worked out that this is, it's going to be further away than that one, so it's E. Diagram shows a large equilateral triangle divided by 3 straight lines into 7 regions. The 3 grey regions are equilateral triangles with side lengths of 5. So these are all 5. And the central black region is an equilateral triangle with side length of 2. So that bit in there is 2. What is the side length of the original large triangle? Well, I suppose the key to that is to work out, if we can work out how much these white lengths are, then we can add them to the 5 and that will give us the side length of that white triangle. How do you do that? Well, everything's an equilateral triangle. So if I consider this equilateral triangle here, for example, could have considered any one of the other ones, then with that equilateral triangle there, I know this side here is going to be 5 and 2 and 5. So the whole of that is 5 and 2 and 5, which is 12. So that means this white edge must be, since that's 5, that must be 7. So that white edge must be 7. So the total side length is 7 and 7 and 5. That makes 19, which is B. Question 17. The first term of a sequence of positive integers is 6. The other terms in the sequence follow these rules. First term 6, I'll just make a note of that. If a term is even, then divide it by 2 to obtain the next term. If the term is odd, multiply by 5 and subtract 1 to obtain the next term. For which of these values of n is the nth term equal to n? For which values of n is the nth term? So I want to work out in the sequence, if I go and have my numbers, first term is 6, second term is, let me think, if it's even I divide it by 2, so that's 3. And the third term, if it's odd, I multiply by 5 and subtract 1. So it's odd, so I multiply by 5 is 15, subtract 1 is 14. My fourth term is going to be, it's even, so I divide by 2. I'm going to keep on doing this actually. It's only up to 16 terms, and that will give the answer. No clever algebraic formula or whatever. I'm just going to keep on going and see what happens. I'm going to work out the 5th term, the 6th term, 7th, 8th, 9th, 10, 12, 13, 14, 15 and 16th term. So if it's odd, I multiply by 5, which is 35, and take away 1, which is 34. It's even, so I halve, it's 17. It's odd, multiplied by 5, that's going to be 60, 85, take away 1 is 84. That's even, so I divide by 2 to 42. That's even, so I divide again to get 21. That's odd, so times 5 is going to be 105, take away 1 is 104. That's even, so divide by 2 is 52, divide by 2 again to get 26, divide by 2 again to get 13. It's odd, so multiply by 5 to get 65, take away 1 is 64, even, so divide by 2 is going to be 32, even goes back to 16. I could keep on going to 8, 4, etc. Now let's just have a look. Which values of n is the nth term equal to n? So when are these equal? I find they're equal at 13 and they're equal at 16. So that's the answer. 13, 16, 10, and it's not equal at 10, so it's 13 and 16 only. Question 18. Periwinkle starts at the origin and slithers anti-clockwise round a semicircle with centre 4, 0. Peri then slides anti-clockwise round a second semicircle, centre 6, 0, and finally clockwise round the third semicircle, centre 3, 0. Where does Peri end this expedition? Let's just draw an axis there. It's all along the x-axis, so I probably don't need a y-axis. I'll put it in anyhow. So that's the origin. Periwinkle starts at the origin, slithers anti-clockwise, so that's going in this direction. And let's mark some of the coordinates off. So that's 1, 2, 3, 4, 5, 6. That's the biggest one I've got. Oh, let's go for 7 and 8. So that's 1, 2, 3, 4, 5, 6, 7, 8. Centre, semicircle, centre 4, 0. So the centre of the first semicircle is there, and so he slithered around the semicircle, which must have the radius of 4, and so that semicircle he's going to slither around is actually going to end up with 8. So he's slithering around that way, and it's a semicircle, so it's running out when Perry gets there, and that's going anti-clockwise. Then once he gets there, Perry then slides anti-clockwise, so it's in the direction around a second semicircle, centre 6, 0. So the centre is there this time, 6, 0, so that semicircle must start here and finish there. It's going that way. That's still anti-clockwise. Okay? So we've got him there, and then finally clockwise around a third semicircle with centre 3, 0. So there's a centre 3, 0, and it goes clockwise, so it's going this way round, so that semicircle must be coming round there. And that's a third semicircle, just check that is clockwise, isn't it? And he must be ending at that point there, which is 2, 0, which is point C. That diagram was vital for that question. Question 19, the shaded region shown in the diagram is bounded by 4 arcs, each of the same radius as that of the surrounding circle. What fraction of the surrounding circle is shaded? So what I want to know the area of the shaded part and divide it by the area of the circle. Area of the circle is going to be easy. If we call this R, and the area of the circle is going to be pi r squared. I just need to find the area of the shaded bit. Now the way I'll do this is actually more of a trick. It's taken me a bit of time to fathom it out, but if I draw a square around the circle, if that was touching the circle, then this side here would be 2r, that would be 2r, and that would be 2r, so the area of the square would be 4r squared. Now from that square, to get the shaded bit, I've cut out 4 semicircles, each of radius r. Yeah, I've cut out one of those, another semicircle's been cut there, another semicircle there, and a fourth quarter circle. I've cut out 4 quarter circles, each of radius r. In fact, that's the same as I've cut out a whole circle of radius r, so the area of that shaded bit is actually the area of the square, take away the area of a circle, so that's going to be 4r squared take away pi r squared, so that goes on top, that's the area of the shaded bit, 4r squared take away pi r squared. Now if I factorise that top bit, I can take r squared outside of a bracket and leave us 4 minus pi inside, and at the bottom we get pi r squared. The r squares cancels to give us 4 minus pi over pi, and well, that answer is actually not there, but this one can be arranged into, if we just take the pi under each individual one, it could be done 4 over pi minus pi over pi. That's 4 over pi, and that's going to be minus 1, so the answer is A. Question 20, rectangle with an area 125 centimetres has sides in the ratio of 4 to 5. What is the perimeter of the rectangle? Let's just draw a quick sketch of the rectangle. Ratio is 4 to 5, so this is 4 to 5, but I don't know exactly the length, so I'm going to call it 4x, where x is a multiplier. Now 4x times 5x, that's going to be 20x squared, is the area, and the area it says is 125, so 20x squared equals 125, so x squared equals 125 over 20. I can cancel down by 5, so that's going to be 25 over 4. That means x is going to be the square root of 25 over 4. Square root of 25 is 5. Square root of 4 is 2. 5 over 2, that's 2.5. So this one here is going to be 4 times 2.5, which is 10, and this one here is going to be 5 times 2.5, which is 12.5. It says what's the perimeter, so it's going to be 10 and 12.5 is 22.5, and we've got it again there, so that makes it 45, which is D. Question 21. The parallelogram PQRS is formed by joining two equilateral triangles of side 1 unit as shown. What is the length of diagonal SQ? SQ, this is a diagonal we want from S to Q. It's a parallelogram and equilateral triangles. I actually want to, is what I'm thinking, is I'd like to just use Pythagoras to find and make this into a right angled triangle and use Pythagoras. Now if this is an equilateral triangle, yeah, this is half an equilateral triangle. So the side here is 1, this is 1, that's 1, this is going to be a half, that's a half. So I know this length here is 2.5. I need to know the height. Now if I know that's half and I know this is 1, I can find the height of it by doing 1 squared take away a half squared, and then square rooting that. So 1 squared take away a half squared is 1 take away a quarter, which equals 3/4. So the height here is 3/4. Sorry, the square root of 3/4. I'm actually not going to find the square root of 3/4. That's going to be h. The height equals that. Sorry, height squared equals that. I'm not going to find the actual height because Pythagoras now goes and says that the length SQ squared equals, which is going to be this, which is 2.5 squared. 2.5 squared plus the 3/4 squared, which is just going to be 3/4. 2.5 squared, that comes to 6.25, 6 1/4. That's going to be 6 1/4 plus 3/4, which equals 7. So SQ is going to be the square root of 7, and that's A.